Hello everyone. Today we are going to see one of the topic from data analysis subject, that is the topic name is F-test. So what is F-test and how to calculate the F-test, we are going to look on that for today. So F-test is a statistical test that is used in hypothesis testing that determines whether the variance of two samples are equal or not. In this we have F distribution. It is a continuous statistical distribution used to test whether two samples have the same variance. The F distribution has two parameters. The numerator, degree of freedom, df1, it's denoted as df1, and the denominator, degree of freedom, which is denoted as df2. Okay, now the formula for F distribution is F value is equal to sample 1 divided by degree of freedom 1, that is df1, and sample 2, degree of freedom 2. Now in this we have hypothesis testing framework for F test. Now in this we have three types. One is left tail test, then it's right tail test, and then two tail test. Now firstly let's see up to F tail test. In this we have null hypothesis H0, where sigma 1 square is equal to sigma 2 square. In alternative hypothesis it's denoted as H1, where we have sigma 1 square is less than sigma 2 square. Okay, in this the decision making standard, it is just said that the null hypothesis is to be rejected if the F statistic is less than the F critical value. Then we have the right tail test. In this we have the null hypothesis sigma 1 square is equal to sigma 2 square, but here the alternate hypothesis H1, it's sigma 1 square greater than sigma 2 square, where the decision making standard can be said as dismiss the null hypothesis if the F test statistic is greater than the F test critical value. Then two tail test, null hypothesis the same, sigma 1 square is equal to sigma 2 square. Then the alternate hypothesis will be sigma 1 square not equal to sigma 2 square, where decision making standard can be said as when the F test statistic surpasses the F test critical value, the null hypothesis is declared invalid. In F test we have F test statistic. The F test statistic, or simply the F statistic, is a value that is compared with the critical value to check if the null hypothesis should be rejected or not. The F test statistic formula is just like F calculate is equal to sigma 1 square and sigma 2 square, where sigma 1 square will be variance of first population, sigma 2 square will be variance of second population. Okay, then we have again, this is for F statistic for large sample. What is for small sample? Then it will be for small sample, it is F calculate is equal to S1 square divided by S2 square, where S1 is variance of first sample and S2 is variance of second sample. Now these are the steps to calculate F test. Okay, step 1, set your hypothesis. Null hypothesis, where H0 the variances are equal, sigma 1 square and is equal to sigma 2 square, as we know, we have seen before also. Then the alternate hypothesis, the variables are not equal, where sigma 1 square is not equal to sigma 2 square. Now the step 2 will be collect your data. We have to collect your data. Take independent samples from the populations. Okay, we are going to also see this example. Okay, then step 3 is compute the F statistic. Then we have to compute it, as we know that F is equal to S1 square divided by S2 square. And now this is to be noted. Okay, always divide larger variance by smaller variance so that we will get F1 greater than or equal to 1. The F value will be greater than equal to 1. Then step 4, determine degrees of freedom. DF, as we know, df1 is equal to n1 minus 1 and df2 is n2 minus 1. Then step 5 will be find critical F value from the distribution table. Choose significant level alpha, typically 0.05. Now this is to be noted. If your f value is greater than the critical value, reject the null hypothesis. Then for step 6, we will see the conclusion that if f is less than equal to critical value, then fail to reject H0, variances are equal. Okay, and if f is greater than critical value, reject H0, then variances are not equal. Here we have to fail to reject H0, and in this we'll reject H0. Okay, now this, is it clear? And the next is example. So probably we'll be looking up to this example by solving it. Okay, now in this we have sample size, sample variance, where this sample size is n and sample variance is s square as they have given, and then we are going to compute the f statistic as from step 3 we are going to start. Step 2 is what? Collecting the data. We have collected the data, and from step 3 we are going to compute the f statistic. For that, f is equal to s1 square divided by s2 square, where we are going to get f is equal to this. Okay, this is a square, so this is s1 square, this is s2 square. Okay, is it clear? Okay, sorry, yeah. So I was just saying this is s square, so this is s1 square, this is s2 square. So we are going to put the value. S1 is 10 and s2 is 5. Therefore the f statistic will be 2.0. okay, is it clear? Now we have to determine the degrees of freedom. For degrees of freedom, we have the formula as I said you before in step 4. You might just reverse and see. In that we have degrees of freedom formula. Now we are going to look it for group A. So for group A, what we are going to see? df1 is equal to n1 minus 1. So this is n, right? They have given n. So this is n1 and this is n2. So for n1 we are going to do 20 minus 1, where we are probably going to get the value 19, and the same for group B. df2 is equal to where n2 minus 1, where df2 is 25 minus 1, where we get the value of df2 as 24. Okay, is it clear? Now next, what are we gonna see? We are going to choose typically a critical value. Yeah, we are going to look up to as step 5. We are going to see step 5, where we are going to choose the significance level, and then we are going to look up the critical f value for these two. Looking critical f value for df1 equal to 19 and df2 equal to 24 at alpha equal to 0.05. okay, and then we are going to decide if the f value is greater than the critical value, then we are going to reject the null hypothesis, where the same conclusion we are going to repeat, that if f is less than equal to critical value, then we will fail to reject the H0, where we are going to say that variances are equal. Now here the f value is greater than 1, right? So our critical value is 2. As we had said it before, that our f value should be greater than equal to 1. So our f value is probably our f value is 2. So what we are going to do is that we are going to reject H0, where we can say that variances are not equal. Okay, is it clear? I hope it's helpful for you. Thank you.